Hi everyone, today we're going to be going over lesson 5.7, transformations of cubic functions. These transformations work just the same as the transformations we've seen all year. So we have transformed linear, absolute value, and quadratic equations before, and now we're simply applying the same rules to cubic functions. So I'm not going to go over this table step by step, but you can refer to it as you need to. There is one spot where I need you to go ahead and make a correction, and that is right here on reflecting over the y-axis. If we have negative x raised to the third power, that's overall going to give us a negative x to the third, because we will have negative x times negative x will give us a positive x squared, but then we multiply by another negative x, positive times negative is a negative x to the third. So please go ahead and make that correction right away so that you're working with accurate information. We're first going to talk about having our parent function x to the third and transforming it to meet the new function g of x. So I want to go ahead and draw my parent function first and then follow that up with drawing my new function g of x and then stating what has happened to it. So my parent function, let's plug in a few values and get a rough sketch of our graph. If I have x to the third and I replace x with 0, I'm going to get 0 for y, or f of x. If I replace x with a 1, 1 to the third power is 1. If I put in a negative 1, negative 1 to the third power is negative 1. And I'm just going to dash this in. I know that it continues pretty steeply towards positive and negative infinity from here. And this is what I'm going to do for each of my problems, because I'm starting with the parent cubic function x to the third. So I can go ahead and do the same thing here and get that over with. All right, so let's go ahead and look at our transformed function for number 1. Number 1 says x to the third minus 5. So refresh your memory a little bit. If we have a negative tacked onto the end, we are looking at something like an f of x plus k, but since the k value I see a negative, that means it's going down. I can prove that to myself by just plugging in some points. If I plug in 0 for x, I have 0 minus 5, and I have moved my spot that was at the origin all the way down to 5. And so I can plot a couple more points. This one's going to be a little bit off the graph, but we can do this and go ahead and plot our transformed function. So the only thing that we have done to this function is we have moved it down by 5. Let's look at another one. Number 2 says that we want to do x plus 1 to the third plus 2. Well, I already know that something tacked on the end moves us up or down, in this case up, and now a plus 1 inside parentheses is going to move us to the left. We can prove that to ourselves by plugging in a couple of points. So if I plug in 0 here for x, I'm going to have 1 to the third, that's 1, and then plus 2. So I'm going to have a point at 0, 3. And then let's plug in a couple more points. If I plug in, I'm going to go in the negative direction here, because if I plug in a negative 1, this whole term will go to 0, and I'll have a positive 2. So at negative 1, I'm at positive 2. And then let's keep going that direction. If I plug in a negative 2 here, overall I'll have a negative 1 to the third power, still negative 1, plus 2, that's going to be a plus 1. And so I can draw my graph something like this. So we can see that this point that was at the origin has moved to the left by 1, and it has moved up 2. So left 1 and up 2.